Shrinking a modern phone down to the size of a wrist seems like a simple matter of scale, but the reality is that every component has to be reimagined to survive in a much tighter, much harsher environment. Inside a phone, space is a luxury. The interior is like a sprawling mansion, with enough room for the antenna to sit in its own quiet, isolated corner, far away from the electrical noise of the battery and processor. A smartwatch is a studio apartment. Every single millimeter is a battleground, where the battery, the screen, and the health sensors are crammed together. This forces the antenna right up against thick metal and interference. Then there is the biological problem. A phone usually sits in your hand with empty air around it, but a watch is strapped permanently and tightly against your skin. Human tissue is mostly water and electrolytes. To a cellular signal, your wrist acts like a dense, wet sponge that absorbs and kills the connection before it can even leave your arm. Because standard phone engineering fails the moment it touches the skin, engineers have to use 4 distinct architectural tricks to get a signal out. Since there is no room left inside that crowded studio apartment, the first trick is to move the hardware outside and use the exterior walls to catch a signal. This diagram shows the smartwatch blueprint. Notice how the top middle ring, the bezel, is physically separate from the casing. By adding metal bridge points connecting this outer ring to the internal circuit board, the case itself becomes the radio antenna. Now they have an antenna, but they still have to deal with the wrist effect, that wet sponge problem where the body absorbs the signal. A typical watch frame antenna pushes radio waves out sideways. These horizontal waves dig directly into your wrist and lose energy. To stop this, a floating metal plate slides into the very bottom of the watch, sitting right against your arm. This plate acts as a shield and a reflector. It bends those sideways waves and forces them to point vertically. Because the waves hit the skin straight on, they bounce off your wrist rather than soaking into it. Turning the chassis into the antenna and using the body as a reflector allows a device this small to maintain a stable connection to the outside world. But physical space isn't the only limit. Bringing high-speed 5G to the wrist usually drains a tiny battery in a matter of hours. Standard 5G is incredibly power-hungry. It requires wide radio channels, up to 4 simultaneous antennas, which is too much for a wearable to handle. The third trick is a specialized version of the network called 5G RedCap, or Reduced Capability. It is 5G designed specifically for the efficiency needs of a watch. RedCap streamlines the connection. By using just 1 or 2 smaller antennas and narrowing the data channel, it provides the speed a watch needs while using only a tiny fraction of the power. However, there is one more challenge. Watches are moving toward edge-to-edge glass screens. When you remove the thick metal frame, the frame antenna disappears. The fourth trick is antenna-on-display technology, which moves the radio components directly into the screen itself. If you zoom in close enough, molecular-level manufacturing allows engineers to print a grid of transparent metal lines directly over the glowing display pixels. These lines are 100 times thinner than a human hair. Placing the antenna on the screen is a major advantage. Because you are usually looking at the display when you use the watch, your hand is naturally out of the way, giving the antenna a perfectly clear line of sight to the nearest cell tower. By combining software compromises like RedCap with invisible nanomaterials, a watch can achieve 5G speeds without a single visible antenna. It takes all 4 of these tricks working together in real time to make a simple notification appear on your wrist. The now frame catches the signal. The bottom plate bounces it away from your skin. The screen provides a clear window for the waves to travel, and the RedCap network preserves your battery life. These combined solutions allow a smartwatch to function in a crowded, wet environment that would normally block a smartphone entirely. Every time you stream a song or check a message from your wrist, you are using a complex system of invisible physics designed to work specifically with the human body.